Hi there, I'm Mr. McWhorter. Welcome to geometry class. Today we're going to talk about the properties of parallelograms. Now you might be asking yourself right now in purple text, what's a parallelogram? Well, it looks like this, but in mathematics we need a more formal definition. So a parallelogram is a quadrilateral, so that means it has to have four sides, in which both pairs of opposite sides are parallel. So in this case, segment AB is parallel to segment CD, and segment BC is parallel to segment AD. So that's a parallelogram, and that's how it's defined. We're going to learn about some of the other properties of parallelograms, but we're always going to have to come back to the definition of a parallelogram being that both opposite sides, both pairs of opposite sides, are parallel. So here's one of the theorems we're going to talk about. The opposite sides of a parallelogram are congruent. So in order for two sides to be congruent, they have to have the same length. Now you might look at side AB and side CD and say, hey, those look like they're exactly the same length, therefore they're congruent, but that's not a formal proof. What we need to do is actually write a formal proof. So if we think about this theorem as an if-then statement, opposite sides of a parallelogram are congruent. The if-then statement would sound like, if a quadrilateral is a parallelogram, then opposite sides must be congruent. So the given statement here would be that our quadrilateral is a parallelogram, and then we'd be trying to prove that side AB is congruent to side CD, and that side BC is congruent to side DA. So let's start our proof. Now what's the statement that we always start with? We always start with the given statement. So we start off by saying, hey look, ABCD is a parallelogram. And why do I know that? Because it was given to me. So now we've said that ABCD is a parallelogram. Well, what else can we say? Well, we have the definition of a parallelogram, so that's pretty much the only information we have at this point, which says that both pairs of opposite sides are parallel. So if I started by saying that this is a parallelogram, the only thing I can really say next is that the opposite sides are parallel. So I can say that AB is parallel to CD, and that BC is parallel to AD. And why can I say that? Because that's what the definition of a parallelogram tells us. Now at this point, we might get stuck and say, well, I've already said everything I know about parallelograms, and so far we really have said everything we know about parallelograms. But we've already proven a lot of theorems about triangles. We haven't proven a lot of theorems about quadrilaterals or parallelograms, but we have proved a lot of theorems about triangles. If only there was some way to involve triangles in this picture. Well, hey look, what if I drew segment AC? I'm allowed to do that. So step 3 is going to be draw segment AC. Why am I allowed to do that? Because you can draw a segment between any 2 points. So I will draw segment AC, and then I'm going to go ahead and label some of these new angles that show up. So now what's going on? I've got parallel lines, and I've got AC coming through them. Well, I remember a theorem we used a lot that was about two parallel lines being cut by a transversal, and then there was a lot of stuff we knew about that. We knew that alternate interior angles were congruent, alternate exterior angles were congruent, corresponding angles were congruent. So which one of those will help us here? It looks like, well, angle 1 and angle 2 are alternate interior angles. So I can say that angle 1 and angle 2 are congruent. But AB and CD aren't the only two sides that are parallel here. I also have BC and AD parallel. And when I look at those two lines being cut by the transversal AC, I can see that angle 4 and angle 3 are alternate interior angles. So I can say that angle 1 is congruent to angle 2, and that angle 3 is congruent to angle 4. So let's say that down here in the proof. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. And why can I say that? Because when two parallel lines are cut by a transversal, alternate interior angles are congruent. Now when I drew segment AC, I cut my parallelogram into two triangles. Triangle ABC and triangle CDA. And I already have a congruent angle and another congruent angle. And so there was a bunch of theorems, or postulates actually, that we could use to prove triangles to be congruent. There was angle, side, angle, side, side. Which one of those could I use here? I've got two angles, and look, they share segment AC. So if I say that segment AC is congruent to segment AC, why can I say that? That is the reflexive property. Now I would have angle, side, angle, side, angle, and I can now say that triangle ABC is congruent to triangle CDA. And it's important that I name it in that order, because if I'm starting at angle 1, A, B, C, I need to start at the angle that's congruent to angle 1. So if I'm starting it at A, which is at angle 1, angle 2 is congruent to angle 1, so I would need to start at C, and then go C, D, A, and end up at the angle that's congruent to angle 4. So if I'm starting at A and ending at C, then I need to start here at C and end up at A. And why can I say that these two triangles are congruent? Angle, side, angle. Now we're pretty much done, because we can say that segment AB is congruent to segment CD, and that BC is congruent to DA, and we can say that because these are two congruent triangles, and these are corresponding parts of congruent triangles, and corresponding parts of congruent triangles are congruent. So we started off with ABC being a parallelogram. We used what we know about parallelograms and some theorems that we know from the past to get to the conclusion that the opposite sides are congruent. So QED, which is Latin for it has been demonstrated. So let's start making a list of things we know about parallelograms. What do we know about parallelograms? Well, one thing we know is the definition of a parallelogram, which says that both pairs of opposite sides of a quadrilateral are parallel. We just proved a theorem that says that opposite sides of a parallelogram are congruent. Now let's take a look at another theorem. This theorem states that opposite angles in a parallelogram are congruent. So, in order to prove it, we would have to start with the information that quadrilateral ABCD is a parallelogram, and then we would have to end up proving that angle B is congruent to angle D, and angle BAD, or angle A, is congruent to angle C, which we could also call DCB. And you'll see in a moment why I named them BAD and DCB instead of just angle A and angle C. So, what do we always start with? We start with what we're given. We're given that ABCD is a parallelogram, and we can say that because the information was given to us. What can we do now? Well, kind of the same idea as we did last time. We're going to draw AC, because that gives us some triangles. It gives us triangle ABC and triangle CDA, and we can use those triangles. The theorem we just proved tells us that segment AB is congruent to segment CD, and that segment BC is congruent to segment AD. So why do we know that? Because of that theorem that says opposite sides of a parallelogram are congruent. We know that AC is congruent to itself. That is the reflexive property. So now we got side, side, side. So we can say that triangle ABC is congruent to triangle CDA because of the side, side, side congruence postulate. Okay, so now we can use corresponding parts of congruent triangles to say that angle B is congruent to angle D, because those are corresponding parts of congruent triangles. We can also say that angle 1 is congruent to angle 2, and we can say that angle 3 is congruent to angle 4. Well, how does that help us? Well, we've already said half of what we're trying to prove. We've already said that angle B is congruent to angle D. But now we need to say that angle BAD is congruent to angle DCB. And how are we going to say that? Well, angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. If we were to add these two angles together, we're adding two equal angles, two sets of equal angles. So when we add them together, they should be equal. So let's see how we're going to put that in a proof. We can say that the measure of angle 1 equals the measure of angle 2. And that's because that's the definition of congruent angles. We can also say that the measure of angle 3 is equal to the measure of angle 4. Same reason. That's what a definition of a congruent angle is. So now if I was to add these two statements together, measure of angle 1 plus measure of angle 3 would be equal to measure of angle 2 plus measure of angle 4, and that's just from adding statements 8 and 7 and 8. And then measure of angle 1 plus measure of angle 3 is equal to the measure of angle BAD. And measure of angle 2 plus measure of angle 4 is equal to the measure of angle DCB, and that's the angle addition postulate, that you can add two adjacent angles together and it's equal to the measure of the big angle that they create together. Now, since I've said the measure of angle BAD is equal to the measure of angle DCB, by definition of congruent angles, we can now say that angle BAD is congruent to angle DCB. So now we've said both things that we're trying to prove. Angle B is congruent to angle D, and angle BAD is congruent to angle DCB. It has been demonstrated. So now we know a little bit more about parallelograms. We have the definition that says both pairs of opposite sides are parallel. We have the first theorem that says opposite sides are congruent. And now we have this theorem that tells us that opposite angles are congruent. There's a couple more theorems that we won't do the proofs of, because we'll leave those for exercises later on. But we see that consecutive angles in a parallelogram are supplementary. So that means that if we call this A, B, C, D, we know that the measure of angle A plus the measure of angle B has to equal 180. Likewise, the measure of angle B plus the measure of angle C has to equal 180. Or the measure of angle C plus measure of angle D has to equal 180. Also, measure of angle A plus measure of angle D has to equal 180. So any two consecutive angles are supplementary. They add up to 180 degrees. And the last theorem is that the diagonals of a parallelogram bisect each other. It's not that they're all congruent. See, this segment is not congruent to this segment, but this segment is congruent to this segment, and this segment is congruent to this segment. So at this point, each one of these diagonals is bisected. So we're going to use that stuff to solve some problems in our next lesson. Talk to you later. Bye-bye.